My name is Chris Yeats, and I'd like to thank the AESC conference organisers for inviting me to deliver the keynote address to today's session on geological surveys now and into the future. My topic today is mapping the geology that matters, the role of Australia's geological surveys in supporting mineral discovery in the 21st century. Before I begin, I should stress that this presentation is delivered in my capacity as Executive Director of the Geological Survey of New South Wales, a role which I occupied from the middle of 2015 to the end of 2020. As the AESC is being held in February 2021, I'll have moved on from that role by the time you see this presentation. I'm going to begin with a simple statement of fact that 80% of Australia's current mineral production is derived from mines discovered prior to 1980, which is now more than 40 years ago. Now, that's a statement that should both give confidence and obviously give pause for thought to the Australian minerals industry. Obviously, the downside of this is that it tells us that mineral exploration hasn't been particularly successful for the past 40 years. But the flip side of that, the fact that we have mines that have been operating for more than 40 years, and indeed in some cases for over 100 years, is that there is potential for world-class Tier 1 discoveries in Australia. We found them in the past, and with the right approach and the right framework and the right exploration techniques, we can find them again in the future. So I'm going to give you a brief history of Australia's geological survey organisations and their support for mineral discovery. And it's a long history. As early as 1849, the then Governor of New South Wales wrote to the British Home Secretary, and his letter in part read, "If the country were examined by a competent geologist, valuable metallurgical resource would be discovered," and went on to say that these would be highly valuable both in an economic and scientific point of view. So it took a while before the Geological Survey of New South Wales was established, 26 years in fact, but since 1875, the point I'm trying to make here is that the provision of pre-competitive geoscientific data to support resource discovery, creating a framework for mineral exploration, has been core to the purpose of the Geological Survey of New South Wales. And indeed, this is the case across the entire country. In fact, in the second half of the 19th century, all of Australia's existing colonial colonies founded geological surveys. The first being Victoria in 1852, and the last being Western Australia in 1886. However, it was a while before we actually had a national agency, with the establishment of the Bureau of Mineral Resources immediately after the Second World War in 1946, which is Australia's first national geological survey organisation. And of course, many of you will know, the BMR became AGSO, and AGSO is now part of Geoscience Australia. And to complete the jigsaw puzzle of Australia's GSOs, the Northern Territory Geological Survey was spun out of AGSO in 1970. So what have these organisations done with regards to supporting mineral exploration over the past 150 plus years? So Australia's first wave of mineral discovery, and indeed most of Australia's major mineral districts, were initially discovered in the second half of the 19th and the very early part of the 20th century. Now this wave of discovery coincided with the formation of most of Australia's state geological survey organisations. But I've said there, perhaps it was coincidentally because they didn't make the initial discoveries. Generally, those discoveries were made by prospectors, many of whom weren't geologists. However, I do think it's very clear that shortly after those discoveries, the geological survey organisations went in and undertook detailed systematic geological studies, which enabled those mineral districts to grow from being prospects, small-scale artisanal mining operations, to the commercially successful mineral districts that we see today. And you can see an example there on the right-hand side of the slide of the Geological Survey of New South Wales mapping of the Broken Hill Line below from 1922. Australia's second wave of mineral discovery after the Second World War can clearly be linked to the formation of the BMR and the national coordination and collaboration which was facilitated by that agency. So the BMR allowed standardised 1 to 250,000 scale surface geological mapping across the entire continent, which was completed by the late 70s or early 80s. It allowed the establishment of a national stratigraphic framework so you could understand the context of geology in different states, even if you hadn't worked in those states before. And it also allowed the start of national geophysical surveying with the initial magnetics and radiometrics and gravity surveys in the late 60s and through the 1970s. And of course, these national data sets, this nationally consistent surface geology, the magnetics and the radiometrics and the gravity, enabled a wave of discovery which ran through the third quarter of the 20th century. Mostly near surface deposits, admittedly, but not entirely so. And the image on the right-hand side there shows that in 1976, the very first gravity map of Australia. And of course, that data set was used by O'Driscoll in the early 70s to target drilling, which eventually led to the discovery of Olympic Dam in 1975. which was Australia's first major undercover mineral discovery. And those national pre-competitive data sets have been enhanced and augmented and expanded to the present day. And I borrowed this slide from my colleague at Geoscience Australia, Richard Blewett. And Richard Blewett likes to call these the crown jewels, or sometimes the family jewels of Australian geoscience. They're world's best. And of course, these national scale data sets provide the fundamental framework that allows mineral explorers to operate across Australia. And they're a truly collaborative effort. It involves Geoscience Australia and all the state and territory geological surveys contribute to and deliver these data sets through their portals. So what's happened with the third wave of discovery? What's happened since 1980? And what have the surveys been doing since 1980? So since the mid-1990s, with the availability of cost-effective geochronological analysis, the availability of GPS navigation, the surveys have focused quite heavily on a second generation of high resolution geophysical surveying in key areas, sort of smaller scale geological mapping. You can see an example there on the right hand side from the Broken Hill district in New South Wales. And this more detailed mapping and this more detailed geophysics, partly led by industry need, has focused very heavily on areas of good quality outcrop with known mineral potential. And as a result of this, because we're mapping areas where major mineral discoveries have already been made, it hasn't led to many significant discoveries. And it begs the question, have geological surveys been collecting the right data for the last 30 or 40 years? And I think that the answer to that question is both yes and no. Yes, from the point of view that the improved understanding of mineral systems and orogenesis, the improved understanding of tectonothermal evolution, and the continental structure that has been gleaned from this more detailed work is a really great platform for stepping off into those undercover terrains where the knowledge is currently lacking. And no, from the point of view that geological surveys for a number of years have been bemoaning the decline in greenfields exploration and an increased focus on brownfields exploration. And if you think about it, if geological surveys themselves, who are supposed to create the framework for future discoveries, are focusing very heavily on known mineralised terrains in the near mine environment, inevitably that's going to encourage an increased proliferation of brownfields exploration. And of course, that's what we've seen over the last sort of 20 years in particular. So I'm going to talk now about the 21st century discovery challenge, and in particular, the challenge of discovery undercover. And this is a map that you'll have seen many times before, some of you. And the grayscale image in the background there is the magnetic image of Australia. The coloured areas on the map show the areas of outcropping crystalline basement, which are prospective for metal deposits. And the coloured dots are Australia's metal deposits. And you can see that almost entirely, although there are a couple of notable exceptions, Olympic Dam being one of them, those coloured dots correlate very closely to the areas of outcropping basement. So it's not just about the ease of access, it's also about the fact that the industry itself hasn't got the courage, for want of a better word, or maybe doesn't have the tools or the framework to step outside of those areas. So you can see on the right-hand side there, a map of Australia's publicly available drilling data, and you can see the drill holes are almost entirely confined to areas of outcropping geology. So I'd say the take-home message from this slide is that yes, almost all of Australia's known metal deposits occur in outcropping areas because that's almost entirely the only place that we've looked with any degree of rigour. And in order to actually uncover the next generation of major mineral discoveries, we need to look beyond the outcropping areas. And this failure to look beyond the outcropping areas wouldn't be an issue, except for the fact, and here's a slide from Richard Choddy, who's spoken many times about this issue, that exploration success has been declining, particularly over the last 20 years. And you can sort of see there, the grey line shows exploration expenditure, and the bar graph shows the value of discoveries. And you can see that somewhere between 2005 and 2010, mineral exploration in Australia moved from being a value creation exercise where the value of discoveries outstripped the cost of exploration to be a value destruction exercise where the cost of exploration is more than the value being created by mineral discovery. And clearly we need to change something in order to address that decline. So this brings me to the topic of today's talk, mapping the geology that matters and how geological surveys can support mineral exploration in the 21st century. So as I said, the question that we need to ask is how can we see the basement rocks undercover? How can we effectively explore that 75% of the continent where the prospective basement is under younger rocks or soil. And here's an example from New South Wales of an undercover deposit which has been discovered, and that's the more than 11 million ounces of gold at Lake Cowal in the Lachlan Origin. And the Lake Cowal deposit is under a thin, roughly 30-metre thick veneer of lake sediment. And so it was discovered, as I've said, but the question we need to ask ourselves is, would we have discovered Lake Cowal if there was 100 metres of lake sediment, if there'd been 200 metres of lake sediment? Clearly an 11 million ounce deposit is worth exploring for, even under significant thicknesses of colour. So what we do know is the traditional approach has been used by the geological surveys over the past sort of 20 to 30 years hasn't been working. And here's an example again from New South Wales. On the left-hand side, you can see our depth of basement map, and the white areas are areas of outcropping crystalline basement, with the dots on the map showing New South Wales as metal occurrences. The orangey colour is down to 500 metres of cover, and the cooler colours are deeper cover. On the right-hand side, you can see an image which shows our data confidence for our surface mapping, magnetics, airborne magnetics and mineral system studies across the state. And you can see the warm colours on that map, the reds and oranges, are confined almost entirely to those areas where we have outcropping crystalline basement. So again, we've been focusing our efforts on mapping near-surface geology, understanding mineral systems in those outcropping areas, and we've actually neglected, for want of a better word, the frontier areas, the covered terrains in the state to a large degree. And what we need to do is we need to expand the search space. As I said earlier, the role of the geological surveys, maybe the core role of the geological surveys, is to create a framework for mineral discovery, to de-risk mineral discovery and mineral exploration in those frontier areas, those covered terrains, the areas that are shown particularly in orange, but also in deeper terrains in New South Wales and indeed across the country. Now, thankfully, we're already doing that. Now, the Southern Thompson Origin project, which was a collaboration between the Geological Survey of Queensland, New South Wales, and Geoscience Australia, and stretched, and I've only shown the New South Wales portion of the project there, but it does stretch into Queensland. We had a related ARC linkage project, which involved the Universities of Newcastle, University of Queensland, Queensland University of Technology. And this was an integrated project which was designed to unlock our covered terrain to exploration. So we undertook new geophysical acquisition, airborne EM, magnetotellurics, gravity and seismic acquisition, on top of a detailed aeromagnetic survey, which was carried out a few years prior to the commencement of the project. We undertook new geochemical analysis of existing drill holes, and of course the new drill holes that we drilled. We did a lot of geochronological analysis, and importantly, we did our own stratigraphic drilling, and we drilled down to basement. Only 7 drill holes over 60,000 square kilometres, which obviously isn't a high density of drilling. But those drill holes weren't targeting geophysical anomalies, they were targeting lithological packages as interpreted from the geophysics. They were deliberately designed to try to unlock the geological framework of the Thompson Origin in New South Wales, and of course in Queensland on the other side of the border where similar work was undertaken. So this was a really successful project from a scientific point of view. It refined our understanding of the depth and the nature of cover, and it also showed that the cover was relatively shallow, with much of it being less than 250 metres across the Southern Thompson in New South Wales. It improved our understanding of the basement geology, the tectonic setting, the structural setting, the evolution of the Southern Thompson Origin, and importantly also showed clear evidence of mineral systems and improved our understanding of the mineral potential of the area. So when we released the data package in May 2018, I regret to say that we didn't see any discernible exploration uptake as a result of that work. Now this might be for a couple of reasons. One is perhaps 7 drill holes in 60,000 square kilometres isn't enough to de-risk exploration sufficiently to encourage explorers to explore in those covered terrains. Perhaps also it was a matter of timing. Those of you who will remember that 2018, we were just starting to come out of one of the worst downturns in mineral exploration in Australia's history. So perhaps we overestimated the appetite for risk at that time, and maybe it's something that will be revisited in the future. But this wasn't the only project of that type in Australia at the time. We also had the Staveley project in Western Victoria, which of course has been very successful both in terms of exploration uptake and of course new discovery with the Staveley minerals discovery. And also the Kumpana project in Western South Australia was another similar project that was carried out at that time. And I'm firmly of belief, and many of my colleagues in the geological surveys across Australia are of the belief, that the future does involve pre-competitive drilling by geological surveys. And of course the MinEx CRC is the main game with regards to pre-competitive drilling. for the next 10 years or so for geological surveys. We're all involved in the National Drilling Initiative, and through that, we'll be generating new pre-competitive geoscientific data over several underexplored, undercover regions across the continent. And you can see the 5 regions there in New South Wales, which are relatively shallow undercover extensions of known mineralised terrains. And we're going to be doing significantly more dense drilling than we did in the Southern Thompson. We're putting a drill hole in 5 kilometres or so. But importantly also, because the NDI is part of the MinEx CRC, which at $220 million is the largest ever effort on the globe in terms of mineral exploration R&D, we'll also have access to the new drilling technologies, the new sensing tools, the new downhole sensing tools, the new real-time decision-making tools that are coming out of the other 2 programs of the CRC. We'll be able to field trial those, and we'll be able to utilise those. And the aim of the NDI isn't just to create new pre-competitive data. What we're hoping is, because of our access to those tools, we'll create a toolkit that will allow mineral explorers to actually step off and explore that 3/4 of the continent where the prospective geology is undercover, rather than just exploring in the areas where we're actually doing our current work. Another challenge for geological surveys in terms of supporting mineral exploration undercover is the need to think about how we deliver our geoscientific data. Now, obviously, a surface geological map isn't particularly useful for undercover exploration, particularly if it only shows the covered units, the covering units. So what geological surveys need to look at is mapping the key geological units and services, whether they be lithological services, whether they be structural services. They need to be mapped and interpreted. They need to be delivered in 3D seamless geodatabases that integrate both the known surface geology, the known subsurface geology, and also the interpreted subsurface geology, geophysics. GSNSW is a fair way down the track for this sort of work as well. Our New South Wales Seamless Geology delivers a seamless package with lithotectonic slices, time slices across the entire state, dating from the Paleozoic right the way through to the recent cover. And we've also got a 3D mapping project in New South Wales. And you can see one of the products there on the right-hand side, which is our 3D fault model of New South Wales, which is available for download from our website. Of course, we need to continue to collect these national scale data sets and need to perhaps collect new national scale data sets to support undercover exploration. Of course, the Australian Airborne Electromagnetic Survey, AusAEM, was rolled out across Northern Australia as part of Stage 1 of the Exploring for the Future program, and will be rolled out across Southern Australia as part of Stage 2. And that provides us with a really nice data set, which actually lets us better understand the depth and nature of cover across the continent on a continental scale, but also gives us information about the basement geology as well. And I'm sort of really excited about the fact that that's going to be rolled out nationally over the next 4 years. And the other example I've shown on that slide there is the AusLAMP, the National Scale Magnetotelluric Framework. And that gives us really good information about the deep crustal lithospheric structure, which allows explorers and geological surveys and researchers to find those fertile prospective areas of the crust in Australia, which need to be focused on in terms of mineral exploration, whether they're outcropping areas or whether they're undercover areas. So, in wrapping up, what's the future in terms of geological survey organisation support for mineral discovery in Australia? So in the 20th century, what the geological surveys did really, really well was they mapped the continent surface, and they provided a framework for mostly near-surface mineral discovery, with a couple of exceptions. So in order to support undercover and deep exploration, so it isn't just about exploring undercover, it's also about having the confidence to drill deep in those outcropping areas, which is something I haven't really touched on in this talk, but is an equal challenge with a slightly different solution. The geological surveys need to move beyond surface mapping, and they need to map key geological units and structures both undercover and at depth in those outcropping terrains. Now, you can go a fair way down this path using new geophysical data sets. That allows models to be generated, but those models have to be tested by subsurface mapping. And the only way you can map the subsurface is using low-cost, rapid drilling, using technologies such as the coiled tubery you can see on that slide, which was developed by the Deep Exploration Technologies CRC, and is going to be deployed certainly in New South Wales, but also elsewhere in Australia as part of the National Drilling Initiative. And ultimately, we need to map the geology in 3D with the drill rig. Thank you for your attention, and I look forward to hearing your questions in the Q&A session later in the presentation.